I'm James Moultrie. I'm a senior lecturer here in the Institute of Manufacturing, and I teach design and also research different areas of design and design management. My first thought would be to think a bit about what you mean by good design and how you might frame or describe good design. For all of us, when we buy stuff, we kind of inherently know what that is, and it's a combination of making judgments with our heart and our head. So if we want to buy a new car, we want it to perform as it needs to perform, carry our children, hold the things it's going to hold in the boot, have space for the golf clubs, whatever it might be. But we also make decisions with our head and with our heart. We want it to be beautiful. We want it to reflect our status in some way. We want it to show people how cool we are, how interesting we are. So good design, whether it's a car, a computer, a laptop, a mobile phone, for most of us embodies those two things. It performs and functions as we want it to, but it also says something about us and appeals to us in some fairly emotional kind of way. Absolutely, definitely, and I think it's a mistake that a lot of people in very industrial businesses make, to think that those ideas of good design, of things being beautiful, of being easy to use, of performing appropriately, are just for consumer goods. They work as much for industrial products as they do for consumer products. When we're making decisions on what to buy, when we're choosing what things we prefer, what we would want to use, yes, there's that bit of logic we apply. It has to perform, it has to function as it needs to function, preferably function better than the competitors. But we will also be looking for something that appeals to us in a more emotional way. So good design has to do both of those. It's got to work well, it's also got to be easy to use and beautiful and appealing, so that that whole set of things together informs the decisions we make. Having thought a little bit about both performance and what you might consider as emotion, the appeal of the thing, for a lot of products it's genuinely difficult to separate these. It's really hard to just design the aesthetics or just design the technology. They have to be done in unison. And good products, it's thought of all at the same time. So those issues are thought early on in the design process altogether. For the performance and functionality, here we're looking at issues such as the basic technical characteristics for the valve, issues of gas flow or regulation, whatever it might be. But also for the business, areas such as design for manufacture, maintenance, serviceability, and possibly even the broader platform of products that might be offered to the marketplace to provide variety to customers, but whilst keeping complexity in the factory producing it to a minimum. And what's genuinely difficult about a design is you can't do any of these things in isolation. You're going to do all of them well, you can't afford to do just one well. Okay, so again, what we're not looking at here is crazy aesthetics and way out forms, but I think we all recognize, even in industrial products, when something stands out, when it is differentiated from the other offerings on the marketplace, and particularly when that product form makes sense. So not just a crazy, wacky shape or crazy aesthetics, but aesthetics that actually provide clarity of what the thing does, clarity of how you might use it. It tells the customer something about the brand of the business and what kind of values the business has. Perhaps explores some new forms and new shapes that haven't been in products before, but without those being irrational. All of those things help communicate to customers whether they want their products to look precious or robust or traditional. All of those things are embodied in the form that the businesses choose to show. In addition to that, those forms are very highly coupled with how we use the product. Here we're really looking at issues of usability and ergonomics. And are those usability, ergonomics issues really clear and really well thought through? And where they are, the form will take care of itself. It will be beautiful and appropriate because it's easy to use and well thought through. Okay, it's a good question. I had a little think about this one, because the obvious examples that most people will trot out when we talk about design come from consumer electronics. But there are many, many good examples in industrial products where we have these really well thought through values of things being beautiful, easy to use, strong ergonomics, as well as having leading technical performance, and these things being highly coupled, not separatable. And so maybe the examples I'll use are examples that I've previously worked on. So before becoming an academic, I worked in industry developing lenses for the film industry. Those lenses have been on the market for more than 10 years now. And when they first came out, they were absolutely leading in how they appeared. They had some very novel aesthetic features that weren't on any other lenses and have since been copied by many of the other lenses. They also had mechanics and optics that were technically ahead of the competition. And particularly the mechanics, one of the key lessons or key ideas embodied in the mechanics was serviceability. We wanted to be able to take a lens apart and put it back together again in the shortest possible time. And we wanted to train an operator to take it apart in the shortest possible time. We had mechanics that were based on a platform, so all of the components where they could be were common, all of the processes were common, so the products could be put together easily and quickly, made efficiently, and a wide variety of products could be offered to the customers. I have similar experiences developing machines for measuring form and geometry in the shop floor. And again, applying the same ideas of making them aesthetically interesting, but really focusing on the performance of them. So I think these values do apply for industrial products, and where businesses get it right, they take a stronger margin than their competitors. These are products that could well be in the marketplace for a long time, and so designing with that in mind is critical. In those early design decisions, we should be thinking of issues such as maintenance. How will it be taken apart, repaired, serviced if we need to? We should be thinking of all of the supply issues. So, can we design this in a way that means it's more effective to distribute in some way or store? We can also think of what happens at the end of the product's life. So in terms of the materials or the recycling, do we have recall? Can we remanufacture some components? Or if we do have to throw things away, what will we do with those materials in order to do that efficiently and effectively? Difficult question. I should say I'm no expert in this field, but I'll offer you some views. Of course, the data and knowledge is only of value if you do something with it, if you use it in some way. And so maybe rather than thinking of the data and knowledge as the thing you want to capture for its own sake, the thing to do is concentrate on the questions that you might want some answers to, that data might help you get answers to. So, for example, how and where are my cylinders used? How frequently are they used? What's the usage rate of particular types of gas? Clearly there's different sorts of data. We could have dynamic data that is updated as we speak. So I could be seeing exactly around the world all the cylinder that's being used, the gas types, all that kind of stuff. And then there's trends data, there's long-term data. Each of those may have a role to play, but again, we need to understand what questions underlies those in order that we can collect appropriate data for the right reasons. Collecting lots of data for its own sake wouldn't be of use. Collecting data because it allows us to do some strategic things can be very valuable. It would be easy to focus on the technology, i.e. the sensors, and how you package those sensors as the thing that you focus on in developing those data product service offers. However, I think that the really difficult issue is not the sensors, not the technology, it's the software. Whatever data you capture, you have to be able to use in some way, analyze in some way, process in some way, and that will all be through some software system. So as soon as you start thinking about embedding technology, embedding sensors in the products, you're creating a much wider system of technology and software that has to work seamlessly together. I think it's a much harder development task to make all of that work, particularly unless you're very clear about exactly what results you might want to get from it. Software is notoriously challenging. And I think as a business embarking on those kind of things, to be able to really plan carefully what that software might be and what it might do would be very important. Well, there's some obvious possible benefits that you could have. The most straightforward one we would all think of is, wouldn't it be great to know if a product was about to become empty? And we could instantly refresh it without the customer knowing that it was about to happen. Somebody turns up on their doorstep with a new cylinder and they can carry on doing what they want to do. And there's all sorts of other reasons why you might think it's useful, other scenarios you could paint. What I think is interesting about that is the implications for the whole system, the whole product service offering, and how that whole system's designed and created. All of a sudden, we might want to think of distributing in a different way, designing distribution centers in a different way, and how that knowledge, that information about product condition influences how we design the whole supply chain. So I think there's lots of good reasons why you could do it, but also lots of implications, having thought of it, for what that might mean for the things you design and the product service system that you design. So on the surface of it, design is easy. We have to design something that works well and is beautiful and is easy to use. Within that, unfortunately, it's very difficult because none of those can happen in isolation. A great product does all of them, not just one of them. So how do you achieve that? Well, you only achieve it by having professionals and skilled people involved in all the bits of it. So for the technology, you need people who understand the technology deeply, who understand and can design things to be manufactured efficiently. To make things beautiful, you need people who are skilled in the art of designing the form and aesthetics, and they have to be involved and work closely with the technologists because these things can't be uncoupled. And similarly for the ergonomics, it's an area that people have lots of specialism in, whether it's physical ergonomics, size and shape of controls and buttons, or cognitive ergonomics, how we relate to, understand, and make sense of the things that we are operating.